Hello again, Kevin Culp from Supermicro here to give you a different simulation on an AMD GPU server we have in the lab. This GPU server is a 2U 2-node. It's an A+ server 2114GT-DPNR. It has the latest 64-core AMD Riser Threadripper inside the server, and we have an A40 NVIDIA card that we're going to show you basically performance metrics collection and lifecycle management of this AMD. So let's crack on and get started and log into the platform. So as I mentioned before in previous videos, we're logging as global admin. Once we log in as global admin, we get directly pushed over to the dashboard. The dashboard is a high level where we collect metrics in different kinds of thermal and power. It's a 20,000 foot view dashboard that gets presented as read-only to users that connect into our management platform. So let's start by launching the compute module of SuperCloud Composer. So once we go ahead and launch the compute module, it provides us with a list of servers that have been registered within SuperCloud Composer. So they went through the registration process and drawer configuration of being added into our pod view, which is the hallmark feature of SuperCloud Composer. So as you can see here, the GPU server AMD is what we have here we're going to be looking at. So let's go ahead and look at the server itself from a front view and rear view. Physical asset information is there available. You can certainly click on this option to get directly into the BMC. You see here our carousel view shows you at a high level what's inside the server. Looks like there's an NVMe drive there. Also, our lifecycle management icons are available here. Shows you that there is an accelerator in this server, which we call it a converged server because it's physically inside the GPU server. If it was attached through some network fabric using our unified fabric directory, we would basically expose it here in this carousel view, showing you an attached GPU or an attached FPGA. Again, icons here for lifecycle management available to you, and then each of the physical asset information, BIOS version, BMC version, manufacturer, so on and so forth, is available here. So it's definitely showing you an AMD Riser Threadripper CPU inside this server. So let's go ahead and look at other information on the side card of physical assets. We have the processor here itself, memory that's inside the server, with DIMM locations, part numbers of the DIMMs, the type of memory in here, DDR4, the size of memory is 64 gig, serial number, and of course the manufacturer is shown, and the health is showing of good standing. And we can go ahead and look at each NUMA region here, but because this is a single socket, we're only showing one CPU, obviously here for its NUMA region. So let's go ahead and look at each other one. We have local storage here. We can click on this option. We see indeed a NVMe drive with a status indicator as failed. And why we see it as failed, because we have not performed deep discovery to determine what's inside this server as far as components are concerned. but it is definitely showing a drive available, an SSD drive for 15.36 terabytes inside the server. Remote storage would be different types of ways we can connect across a network fabric, such as a PCIe switch using direct attached. Various other options we can go ahead and look at from a network fabric perspective. NVMe over TCP would be an RDMA Rocky connection across a JBOF, or perhaps if you had connected servers across a physical link, such as Ethernet, initiators and targets and discovery that we set up within SuperCloud Composer for our storage pools. iSCSI storage, if you wanted to go ahead and boot from SAN, we don't have any iSCSI storage drives connected because this particular system is not booting from SAN. Adapter information. Let's look at NIC, what we see here. We definitely see an AOC LAN card showing you a link state of up. So we have a physical connection to our first port of our LAN card. Shows you the link state is up. So this is definitely dynamic. We're showing the LAN 2 interface is down, collecting vital information of an Ethernet interface. You notice here we color code the link state of our interface as green to show you that we have physical connection, and it also shows you the slot ID on where this LAN card is physically connected within the PCIe slot. So all vital information we would definitely expose within our platform to help you go ahead and make those data-driven decisions and be able to monitor and manage your infrastructure. Let's look at the GPU itself. The GPU is an NVIDIA A40, indeed it is. We have slot identification of where the GPU is physically located. Our manufacturer is obviously NVIDIA A40, showing you the health, serial number itself, and then also firmware version. Let's go ahead and expand the site location. We indeed see some other information here indicating the memory manufacturer that's part of this GPU itself, and a memory part number. And then let's look at FRU. FRU information definitely is here for each of our servers, our Supermicro servers. We have information here such as serial number, part number, so on and so forth. So I wanted to just kind of talk about a little bit of our production facility here. So when a server basically goes through what we call the CBurn process, where there's extensive testing on our servers, several days, we run through various tests to make sure that the system is definitely of good quality before we send to a customer. So our production team, when they go through this process, they burn in information associated with the FRU and DMI before they ship it out to our customers. So again, DMI, we have system baseboard information. All is here that you can go ahead and manipulate those attributes for both FRU and DMI. So let's jump over to the performance metrics, where we're actually collecting data from this GPU. First thing we can do is by hovering over our tooltip, we show you again the slot ID and also the type of GPU that's inside this server. We can also go ahead and look back in time on a look back window to show you historical trending and how this GPU is performing. And then we also have the ability to change the poll times in which we collect data from this GPU itself. So let's go ahead and set it to 10 seconds. So it's a 10-second poll that we're going to go out and retrieve various data points from the GPU. This dashboard is customizable and it's Grafana-like in nature because we can go ahead and move things around within the dashboard to look at what we want to pull as far as metrics are concerned. So this information is definitely customizable. And we collect various different performance metrics from this GPU server. So by clicking the plus sign, we can go in and look at and pull all these metrics that you see on your screen here from the GPU server. So you can go customize your own dashboard to look at what information you want to pull and how well your GPU is performing, such as temperature collection, frequency, number of PCIe retries, GPU utilization, copy operations to the GPU memory, so on and so forth. So very useful when you're running some type of AI workload on this platform, to be able to immediately be reported on the type of metrics and how well the GPU is performing. Again, different measures in regards to how we collect the data, such as min and max, sum and average, and then definitely here showing you, for example, the type of performance statistics you want to chart. So let's just go GPU temperature and we'll do sum average. And then you have a drop down to show you different types of charting that you can collect, whether it be a time series line chart, which would be a linear type of graph, versus min-max, gauge meter, raw table data, or definitely a pie chart. So all of these are collectible. So let's go ahead and use the pie chart for the GPU temperature, and then you can go ahead and click small here, and then it will immediately create a chart for you, showing you here the average temperature. Of course, the average temperature is 100%. It doesn't really fluctuate. It stays around the 28%. So not really a good example of a pie chart, but certainly because we don't have a lot of data points to basically show you to represent really the appliance average GPU temperature. But you can see that we can create different charts associated with the performance metrics. So that is, in a nutshell, again, AMD processor, AMD platform GPU, which is a 2U 2-node that we are collecting performance metrics. We're performing lifecycle management on the AMD. This is all I have to show you at this juncture. Thanks for joining, and we'll see you next time here on SuperCloud Podcast. I'm Kevin Culp signing off. Thanks again for joining.